All right, organic. I'm gonna get started. Okay, so what we are talking about for today's lesson is about polymers. Something to keep in mind with polymers, let's give it a definition. So a polymer is just a long chain of repeated units. So make sure that focuses. So it's a long chain of repeated units. The thing to keep in mind with this question is they'll ask you to make them. They will also ask you to break them. So you need to be able to go in both directions when we're doing with polymers. So make sure you can put them together and take them apart. Okay? Most cases they ask you to put them together, but I can show you what it looks like when you take them apart. There are multiple ways to make polymers. For the level 2 chemistry course, there's only one that they examined, but if you guys take level 3 chemistry, you're actually going to learn another method as well. The method that we are going to be talking about is addition polymerization. Now, excuse me, I'm going to be switching back and forth between the Z and the S because I grew up in the States, but I'm mindful we spell British, so I think it's supposed to be an S, but my brain went Z first, so it's going to interchange every so often. I'm sorry. So when we talk about addition polymerization, in order for this to occur, we need to start with an alkene. So that's any organic molecule with a C double bond C. And what we're going to do is we are going to break the double bond in order to link these monomers together. So it's exactly the same as the addition reactions that we talked about in our previous lesson last week. So last week we talked about having the alkenes and all the different ways we can break it in order to make them. And let me actually go find the notes. There we are. So if you look at our handy dandy little table summary, we talked about addition reactions are the ones in blue. So I start with an alkene, I break the double bond, and I add things to it. Say, for example, I'm adding water, or I'm adding alcohols, or I'm adding a halogen and a hydrogen, or I'm adding hydrogen, or I'm adding two bromines. This one is, again, another type of addition reaction, except instead of adding things to the organic molecule itself, we're actually just adding the molecule together in repeated fashions. So that is what we're talking about with our polymers. Now, depending on the polymer, you can get lots of different properties. It's a really useful building block. In fact, all of the plastics that we're dealing with are all examples of something made up of polymers. So depending on what you have on that organic molecule and things like that, you can end up with different types of plastic. For example, like with my document camera here, we have a wire, and it's a very soft plastic. It's flexible. So this is a certain type of polymer that allows that flexibility. You can change, again, the polymer and change the structure of it, and you can get other things that are like a hard plastic, like my mouse or the chair we're sitting on, so it doesn't actually change shape when we sit down on it. This, like I said, is another form of a plastic. It's the clear pocket ones. Again, it's more flexible than this guy here. So lots of different polymers that then allow us to have lots of different properties. So that's why we see a lot of plastics being made up of, and that's why we have a different variety of plastics as well. In fact, the word polyvinyl, you know how we talk about those old records and we call them vinyls? It's made up of a polymer that is referred to as a polyvinyl. So it's a certain type of plastic is basically all that is. So that's something to keep in mind when we're looking at it. Let's look at an exam question so I can show you guys how you put it together. The SciPy pages are great, but if you understand the concepts, I would suggest you're better off going to No Brain Too Small so that way you're actually practicing exam style questions. So they're basically just there depending on where you are in your learning. It's like I said, always, it's not a tick boxing exercise. So let's look at this question here. So this is from the 2013 exam. This is the one that was taken last year. Now here is an example of a monomer, and they've drawn it out for you, and they want you to draw 3 repeating units of that monomer to show it being put together as a polymer. Something to keep in mind when you're looking at this is that they've drawn it as a straight chain, and that can make it a little bit conceptually difficult to kind of see it as a polymer. So let me just redraw it so that way it's easier to put together. So I'm just going to copy that onto my piece of paper, and then I'm going to redraw it for you guys. So that's C, double bond C, with a single bonded C, and then the act is 1, and then you got the hydrogens, and then you have that there. See? It's drawn kind of like that. Okay, so let me just copy that down. There you go. So first question is a nice little refresher. When I look at this guy here, does it form geometric isomers? Yes or no? No, because you see how there's 2 hydrogens there, so that's obviously going to rule it out. If I underwent an addition reaction, would this have to use Markovnikov's rule? Yes, it would, because it's not a symmetrical carbon. If it was, actually you can't have a symmetrical carbon because it's only 3 carbons there. So just a nice little refresher to test it. So you can see how with organic chemistry, the challenging thing with it is that everything intertwines together. So it's really hard to get started on organic chemistry if you don't actually have all the information. You can't just like study sections of it and then do some of it. You have to actually learn all of it first. So we know that. Now, something that you have to keep in mind with with polymers, I like to redraw my monomers just to make it a little bit more obvious of what I'm trying to put together. So I personally redraw this as C double bond C. I have an H, I have an H, I have a CH3, and I have an H over here. So I'm just redrawing what I have up here to look conceptually different. So that way when I put it together as a polymer, it's a lot easier for me to do it because I don't want to confuse what this guy's doing here. Are we okay with that? All right, so when I am trying to convert this from a monomer, so these are the individual pieces, polymer is putting them all together. So the way that I personally like to do it is I like to just draw my monomer a couple of times. So I'm going to repeat this twice more. I'm just changing colors just to show you that it's 3 different monomers. Sorry, not 3 different, 3 monomers. They're all the same molecule. I have 3 monomers like that. Are we okay with how I've done that? All right, now let's put them together. So all I need to do when I'm adding these guys together is take away that double bond and then just tie them like that. So now I've put them together and I've had some little end pieces, and then I just draw a square bracket around it and I write N, and that tells me that that is the repeated unit for the polymer. I'm just going to twink out the little lines so we can see again that they're single bonded now. So that's how I personally do it. Are we okay with that so far? That's all you're doing. They can also ask you to go in reverse, so they can give you this polymer here, and they'll ask you, okay, make the monomers that make up this polymer. So again, you're just looking to see where that repeated unit is, and then you're just isolating it. So you have to be able to go forward and backwards with this question. Questions, concerns, or comments? Or is that pretty straightforward? All right, keep going. Okay. Let me point out on your CPR quiz that they've done something funny with their, I don't like the molecule. I did take it from a mock exam, which are always a little bit harder than the actual exams, but you can see they've drawn a molecule here that looks more complicated. It's not what it looks like. Just do the exact same thing that I did and break it up and do it up and down. I'll start drawing it just to get you guys going on it because I know that's probably going to be something that throws you. So that's CH2 double bond CH3. I also don't like it because I've stuck in what is essentially a level 3 molecule in there, and this is supposed to be a level 2 mock. So just kind of keep that in mind. I looked through the other mocks, but the reason why I picked this question is it has this extension bit here, which I saw in the 2023 exam, and I want you guys to practice writing up that justification. So I've drawn it here. the exact same way that they've drawn it on the exam, but we're going to change the format like I did with these two. So that way it looks easier for me to comprehend. So I would do C, double bonded C. I would do H and H, and then I would do CH3, and then C double bond O, O, CH3. That is how I would rearrange it so that way it's a little bit more obvious where my alkene is. And then we just repeat that molecule and add them. Does that help? So I don't want you to freak out when you see something like this. You just got to rearrange it to look like that. And then you can very easily branch them all together. Questions, concerns, or comments? So that is on the CPR quiz. All right, I'll give you guys another second, and then I'll show you guys the next question that they often ask. So this used to not be asked as a question. They just recently started doing it, and I was like, oh, that's interesting. I don't think it's a bad question. I feel like it's a fair question. Okay. So the other thing about polymers that are different to the alkenes is that the polymers are far less reactive than their monomers. So the monomers, we are talking about the alkenes. Oh, excuse me, that was a burp. The polymers, we're obviously talking about the repeated structure. And then they're basically asking, why is the polymer less reactive than its monomer? So the thing we have to keep in mind, let's go back to our little sheet here, and I can show you guys where exactly they're referring to as this question. It's a good question. So when we look at alkenes, do we see how many reactions it can do? So that means it's very, very reactive. And in fact, if I wanted to test for it, I would use bromine water. And if I just mix these two things together without any heat, without UV light, it will automatically react and decolor. It's a very fast reaction too. And hopefully on Thursday, if I'm organized enough, we will be able to do these reactions. You guys can see it. However, when we look at the haloalkanes, which is what essentially a polymer is, it's a long line of alkanes basically together. It's all single bonded. When we look at the alkanes, they are far less reactive. And in fact, if I want to do a reaction, oh no, that's the haloalkane right there. There you are. The alkanes, if I want to substitute out a hydrogen for a bromine, it actually requires me to provide heat and UV light as catalyst to get that reaction to go. So this is far less reactive. It can still react, but not as well. So same thing applies when we're talking about our polymers. When they're in the monomer form, these are very, very reactive because of that double bond there. When they're in the polymer form, we have lost that double bond, and so they're now just single bonds. It's saturated, so it doesn't react as well, which is, again, another reason why we want to form these polymers and why we use them for things like plastic and stuff, is because they don't react with the environment around them. I just hit myself in the head. Are we okay with that? So it's just a recent question that I've seen popping up, and that's why I picked that one for the mock exam. The answers for the mock exam are on there, and then there's also the answers to the marking schedule. I just want to show you guys it so you know where it's going. I just want to see question 3. Oh, here it is. We're already there. So this is more realistic to what they're going to give you difficulty-wise. They're not going to give you something super complicated like the mock. So this is what we're looking at. So the repeated unit, if you were able to correctly draw that, it was just an achieve point because it's not a whole lot of challenge there. But the explanation bit, that is the stuff that's going to get you to that merit and excellence kind of component. So first thing, explaining what addition polymerization is. That's breaking a double bond to add things together to form stuff that are single bonds. So the reason why I can add to the monomer is because I'm breaking double bonds. It's an unsaturated molecule. It's an unsaturated molecule. So achieved is just tell me what addition reactions are, what polymerization reactions are. Merit is actually explaining what addition reactions are and why they're there. This one here, again, is talking about the reactiveness to it. So just saying that, it's an unreactive component. And this question in particular, they were asking about face mass and why we're using face mass as our polymers instead of monomers. Let's think about that. If I put something on my face, I don't want it to react with my face and then cause me to have a rash or something like that. So that's why we're using things that are unreactive. So, and it's also not going to react with whatever else you put on there, like any moisture or oils or things like that. So, tying it back to the question, in this case, it talks about, again, the single bonds are going to be very reactive. So Again, the achieved is just recognizing that polymers are less reactive than the monomers, explaining why it's good for mass. So you get, again, tying back to the question, this was the explaining it component, and then if you manage to get both of these endpoints, that's what the excellence point was. So just showing you guys how that question builds, because I don't think, as much as it's hard to start organic chemistry, I would say organic chemistry is quite easy for the excellence because there's not a whole lot of explanation to it. The process is showing understanding. Questions, concerns, or comments? All right, so depending on where you guys are feeling, you're welcome to go back and do those side pages there. I only suggest you doing that if you don't feel confident with the material, you want a little bit more practice. Otherwise, you're better off moving to the no brain too small and actually doing those exam questions. And then once you feel like you're confident on that, you can give the CPR quiz a go. Cool. All right, that's it.